Okay, so now with this example here, we have these bases B and D for R2. Now, because we have these representations here, right? So now, as a little bit of a review, you should know how we get these two vectors, right? Because all we're doing is we want a representation with respect to D, right? Well, we're using the identity mapping for 2, 1, so we're getting a vector in the codomain with respect to the basis D that represents the same vector. So vector 2, 1, as you can see, is represented by this one. So remember, this is the coefficient matrix. So if I take a -1/2 times this plus 3/2 times this vector, I'll get 2, 1. Okay, so this is the representation with respect to the basis D. Okay, and similarly over here for 1, 0. Okay, so just keep that in mind. Just a little bit of review of what we've done in the past. Now, because that these are the representations, then the change of basis matrix is this. So we're just going to join those. Oh, no, not B. So this is the change of basis matrix. And we're just going to join these two vectors to give us the change of basis matrix. Okay, and so now let's look at E2. Okay, so this is the representation for E2. So if I take the representation with respect to B of E2. Now remember, E2 is 0, 1. Okay? And that's equal to 1, -2, and you can check that. Okay, how do you check that? Again, with respect to B, so basis B, we can get the representation of E2 by, again, this is the coefficient vector, right? So if we take 1 times this vector minus 2 times this vector, we'll get 0, 0, 1, right? And it's easy because you can go 1 plus -2, or excuse me, 2 plus -2 is 0, right? And then 1 plus 0 is still 1, right? Okay, anyway, so we've got that. And now, what do we do with that? Now, the matrix does the conversion, right? So now what happens is, now if I take this mapping, right? So this is the representation with respect to B. Now, if I multiply by this identity mapping, then it'll give me the corresponding representation of E2 with respect to D. So let's do that. So if I do that, I get -1/2, -1/2, and so on, times, oops, times the vector 1, -2, and I'm going to get this vector. And it's easy to check. Right, it's easy to check that because, again, this is equal to now the representation with respect to D of oops, E2. And that's easy to check.